All right, so we'll finish looking at sine and cosine today in depth in terms of graphing, and we'll look at how we graph multiple transformations. Okay, everything you already know about graphing individual transformations stays exactly the same. The only thing you have to do is do the individual transformations in a certain order. And the reason is, think of it like PEMDAS. Okay, if you do arithmetic in a different order, you might get a different answer. Okay? Same thing here. If you don't do the transformations in the right order, you might get a different answer, sometimes. Right? Just like with PEMDAS, sometimes you can go out of order and you still get the right answer. It depends on how many operations are in the problem. Right? But in general, if you follow this order, you'll be guaranteed to always get the correct answer if you do everything correct. Okay, so the first thing you want to do is a phase shift. Okay, always handle your phase shift first. Okay, the next thing is period change. Okay, and sometimes the way I remember these two, it's almost like you're solving an equation. If I was solving this equation, the first thing I would deal with is the addition or subtraction. Right? That's like the phase shift. The next thing I would deal with is the number in front of x. That's like a period change. Okay? So it's kind of like the order when you're solving an equation. This first, and then that last. That makes sense? Okay, yeah. Okay. The next thing you deal with is your vertical stretch. And the last thing you deal with is your vertical shift. Now, within step 3, you also could have a reflection. Okay? When would you have a reflection in step 3? Yeah, Tom?
Stretching by a negative.
Yeah, if you have a negative number for the vertical stretch. Okay, so it could be sine or cosine. Okay, so there's the numbers corresponding to what I just did. So if C is negative, then you also would have a reflection. And that would be over the x-axis. Okay, so reflect if necessary. And it does not matter if you do the stretch and then reflect, or reflect and then do the stretch. It makes no difference. Okay. So any questions on the order you have to do the transformations in, or the numbers in the problem that identify what the transformations are? I tried to match them up, if that's what they are. All right. So let's, you still copying?
Yeah, I was copying the last one.
All right, so let's try graphing this one. First thing I want to do is just identify what's happening. Who can tell me what's happening here in the order that it should happen in? Allie?
I should have the shift to the left and pi over 2.
Yep.
And then we have a vertical stretch of 2.
Exactly. So those are the two things we're going to do. So and that's the order we're going to do them in. All right. So for now, I'm going to pretend like this problem, the 2 isn't there. Okay. I'll deal with that after. So I'm going to find a table for sine x plus pi over 2.
Multiple tables.
Mm-hmm. Okay, so start with your phase shift. What's going to stay the same for a phase shift? Y's. Okay, what are my y values? 0. Now, we're going to take all of our x's, and what are we going to do to each x value? Subtract pi over 2. So we're going to minus pi over 2. 0 minus pi over 2 is negative pi over 2. Pi over 2 minus pi over 2, 0. What's pi minus pi over 2? Pi over 2. The next one? Yep, just pi. And the last one? 3 pi over 2. Okay, so now you've taken care of your phase shift. So now we're going to do the vertical stretch, okay, the amplitude change. When you do an amplitude change, what values stay the same? The x's. So now we're going to copy the x's, not from the original table, because that would undo the phase shift. We're going to copy the x's from the table we just had. Okay? So you've got negative pi over 2, 0, pi over 2, pi, 3 pi over 2. And what am I going to do to all the y values? Yeah, I'm going to double all the y values. What would you get if you double them all?
0, 2, 0, 2, 0.
Yes. So that is your table. And that's it. It's a multiple transformation. Okay. If there was a third one, like let's say there was a +4 on the end, now I would do a +4 to all the y values. In your head, if you can double something and then add 4 in the same step, that's okay. But sometimes if I try to do too much at once, it confuses people. Okay, so I showed each individual transformation. All right, so now on your grid, does anybody want graph paper? I have graph paper if anybody wants it. Nope. Okay. So negative pi over 2, 0. Pi over 2, pi, 3 pi over 2. It's probably better if you put your labels at the bottom like I have here, because then when you sketch it, you're not going to draw through them. So if you have a grid set up like that, that's actually a little easier to work with. Y values need to go from 2 to -2. All right, so now we've got negative pi over 2, 0. 0, 2. Pi over 2 back to 0. -2 and 0 again. So those are my 5 points. Again, depending on how you set up your scale, you may or may not see a lot of difference here between the original. You might say, oh, well, that just looks like all it really did was a phase shift. Well, that's because I changed my y scale. Okay. The original would be something a little bit more compressed. It would only go half as high, and it would be shifted back starting at the origin, not starting right there. Right. It's a little hard to see my axes here, but that's x, and that's y. Okay. Any questions on that? Okay, that's it. Now, what if you switch the order of the transformations here? Would you have still gotten the correct answer?
Yes,
Yes, in this case you would have.
because you only do y on one of them and you keep x on the other one.
Exactly. If you're only doing one transformation on each axis, technically it doesn't matter which one you do first. Okay? When it does matter is when you start doing multiple transformations on the same axis. Okay? So like if you were going to do, let's say, a vertical shift and a vertical stretch, it makes a huge difference if you take a number and let's say you triple it and then add 7. Or you add 7 first and then triple that. That's a huge difference. All right? So when you start doing multiple transformations on the same axis, that's when it matters. All right, so this one, let's see, did I have another one below that? No. So we got 3 cosine 2x plus 1. Okay. First, just a general question. Is this a problem where there are going to be multiple transformations on the same axis?
Yeah.
Yes. So now the order does matter. Specifically, on which axis is the order important? The y. Because you're going to triple and add 1. Okay? And if you wonder why, just take a number in your head, triple it and add 1, and then reverse it. Add 1 and triple it. You don't get the same answer for every single number. Okay. All right, so first transformation I'm going to deal with is what? The period change. Okay? And that has to do with what number? The 2. So I'm going to keep my y's the same. Okay, y's for cosine, 1, 0, negative 1, 0, 1. And now, what do you do to all your x values? Yeah, divide them by 2 or multiply them by a half. Okay, so what are my x values going to be? 0? Pi over 4? Pi over 2? Yep. And pi. Okay, if you write everything with a denominator of 4, you see the nice pattern. Okay, but any questions on those x values? Okay, so that takes care of this. What's the next transformation I deal with? The vertical stretch. Okay, and what values will that affect? That's going to affect the y's. In fact, the x's are done for this problem. Okay, so next time I have to write those, I will just copy and paste them. Okay, what am I going to do now to all my y values? I'm going to triple them, so I'll get, yep. Okay, and now we have a graph of 3 cosine 2x. Next step is to take all of that and shift it up 1 unit. Okay, and this is my final table. All right, when I shift up, Amanda, what column is going to stay the same? Yeah, the x's. So in your notebook, just hit your copy and paste button.
I should have made touchscreen notebooks, Chromebooks you can write on.
They probably, I think they do, but we don't have them. Right? They probably have a touchscreen.
You know, harder.
All right, so we've got
I know, how do you get your smartboard so calibrated? Half the time, like, teachers will try to use it, they write here and it shows up over there.
I don't know, it just stays calibrated.
And literally every other one of our teachers are like,
I'm kind of good with it too, the technology stuff. So maybe some people just not sure how to calibrate. I don't know. What are we going to do to all the old y values? Add 1. So where are we going to be?
4,
0,
negative 2,
Oh, it's actually going to be
1, and 4.
1, negative 2,
1,
4. All right, so some of this, if you, like I might ask you questions about this and say, what's the range? All right? It's very easy, hopefully from the table, you can see the lowest and the highest value. But without the table in your head, you have to think about it a little bit. Like, okay, it would have been between 1 and negative 1, but I tripled it, so it's between negative 3 and 3. But then I added 1 to each of those numbers. So now instead of negative 3 and 3, it's 4 and negative 2. All right, so sometimes you just have to think it through to figure it out. If that's all I ask you, you don't have to make a table. All right. What's the period of this function? Pi. Yep. What's the amplitude? 3. And the range, I just said to you, negative 2 to 4. Okay, so let's graph it. I need to go from negative 2 to 4. So what I'm going to do is just put another line in. This will be 0, 2, 4, negative 2. Okay, x's, we're just going to space them equally every 45 degrees. So we've got 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay, now just graph your points. So we got 0, 4. Let me make it a little smaller so I can see. Pi over 4, 1. So about right there. Pi over 2 is negative 2. 3 pi over 4, we're back at 1. And pi back at 4. Okay, so there's my graph. Any questions on how I put those dots there? All right, now just draw it. Trying to make it look like the concavity is switching at those 2 points of inflection that are in the middle. Okay, that's the best you can. Okay, so questions on anything in that problem? All right, does anyone think they need to see one with a phase shift and a vertical shift? I don't think we didn't do one exactly like that. This one had the vertical shift, but it didn't have a phase shift. This one has a phase shift, but it had an amplitude change, so it was a little different. But any questions on how you do one like this? Okay. How about one if I gave you all 4 transformations, like if there was a phase shift in this problem? Any questions on how you would do that? Okay. So the big thing that would happen if you had a phase shift is the first x coordinate wouldn't be 0. Okay. Anytime, if you don't do a phase shift, your first x coordinate is always 0. Doesn't matter what other kind of transformation you do. Nothing affects the first x value except a phase shift. Always. All right, so this one, they're asking us to find a complete graph. Okay, so by the directions, what are they asking us for? Yeah, they're asking us to use a graphing calculator. And then they want us to find the domain, the range, the amplitude, and the period. Okay, let's see if we can do some of that before we graph it. What would be the domain of this function? All real numbers. You don't even have to think about it. If it's sine or cosine, it's always all real numbers. Unless the sine or the cosine is in the bottom of a fraction, but then it's not really sine. It's flipped over, so it's really secant or cosecant if you put it in the bottom of a fraction. Okay. How about my range? Yeah, Allie?
4 to negative 4?
Yeah, normally it would be negative 1 to 1. So range, I'm thinking, all right, let's look at the 2 things that could affect range. That's vertical stretches and vertical shifts. There is no vertical shift, but there is a vertical stretch. So take what your range would be, negative 1 to 1, and quadruple it, negative 4 to 4. And it is important to put the brackets because you do reach negative 4 to 4. So that's one way to write it. Or you could do it this way. I don't care. Or you could write the whole thing as a sentence. The range is negative 4 to 4. Okay, most people pick one of those notations. Amplitude. What's the amplitude of that? 4. And what else? Period. What's the period of this? 2 pi over 3. What does that mean? The period is 2 pi over 3. Explain what that means to me. Yeah?
Well, for a normal sine and cosine, the period would be 2 pi. So just to figure out, you just have to take the coefficient of x and divide 2 pi by it. That means the sine or cosine repeats 3 times in 360 degrees.
Yeah. All right. So we know that within 360 degrees, this function is going to repeat 3 times. So what if I only wanted to see one period on the screen? What would have to be the width of my screen, how many degrees or radians. It would have to be 120 degrees or 2 pi over 3 radians. Now, there's a lot of ways to do that. One way, just to keep it simple, if I did it in degrees, I could go 0 to 120. That's a width of 120. I could go negative 60 to 60. Does everybody agree that negative 60 to 60 is 120 units apart? Okay, there's a lot of ways you can set your window to see one period. Generally, what we like to do when you see a period is don't cut it off in the middle. Okay? This would be a very nice window to look at one period of sine. Okay. Technically, if you wanted one period of sine, you could look at what's in this box, because you're starting on the, actually you'd have to go a little further over. Because you're starting on kind of a downward slope, and then you're ending on the downward slope. So that is one period of sine. But you kind of started and stopped it at some weird points. Why not just do it like that? Start it right on the x-axis, stop it right on the x-axis. Nice and neat. All right, so let's graph 4 sine x. 4 sine 3x. All right, so we're going to do 4 sine 3x. And I'm not going to do zoom 7 because that's it's going to pick the x min and max for me. I want to type it in myself. So I said that if we go from 0 to 2 pi over 3, you would see one period. Let's do 2 periods on the screen. So I'd have to go from 0 to what? 4 pi over 3. What's the lowest that this function goes? So let's go negative 5, and then the highest. Yeah, 4. So let's go to 5. So if I did this right, you should see exactly 2 periods on the screen. The y max, anything above 4 is okay. Don't set it like up to 200 because then it'll just look like a horizontal line. Okay. But that's exactly 2 periods of the graph. Okay. And when they ask for the complete window, I would want you to write down those 4 values that we always do. X min and max, y min and max. You don't have to write your x max as a decimal.
What did you put in there for x max?
4 pi over 3. Okay, your calculator, if you type a calculation in like I did, it's going to change it to a decimal, which is fine. But when you write it on paper, you could just write 4 pi over 3. Okay. Questions on that one? All right, so let's do this one. Find a complete graph and do the domain, range, period, and amplitude. Okay, so why don't you guys take a second and try that one on your own. And then when you're done, I want you to find a complete graph that would show 3 periods. Give me a window that would show 3 full periods. All right, so a lot of things they're asking us for here are things you really can figure out without a graph. You shouldn't need a graph to really do anything they're asking. But they are asking for the graph, so we'll do it after. What's the domain? Yeah, you can plug in anything you want for x. These are all real numbers. The range. What's the range? How about Francisco? Do you think you got the range? Yeah, it's negative 3 to 3. And it is important you put the brackets because it does reach those numbers. The period. This is going to be important because I asked you to show 3 periods. So first we got to find the length of 1 period. It's 2 pi. So we'll come back to that when we set our mins and maxes. And what about the amplitude? The amplitude is 3. All right, so let me type it in. 3 sine x minus 1. And how would I show 3 periods on the screen? What does my x-axis width have to be? How many units?
1 to 6 pi plus 1.
Yeah, if we wanted to make it so it's not cut off at a weird spot, you have a phase shift in there. So if you just did 0 to 6 pi, yes, that would show you 3 periods, but you're cutting it off at kind of a weird spot. If you look at your shift and you say, okay, this graph has been shifted right 1 unit. So I'm going to take my viewing window and I'm going to shift it right 1 unit. Now if I do that, okay, I still have a window that's 6 pi units. It's just been shifted with the phase shift. So now it starts at a nice spot. And you get 3 full periods. So any questions on how we got the window for that one? Yeah, question? You got a better graph than I did? A different one. Yeah, there might be other answers. I mean, there was nothing wrong with the first answer that didn't have the +1 to the window. I just think that looks a little cleaner to me. Starts at a nice spot. Okay. But unless I specifically asked for you, make sure your window doesn't cut something off halfway through a period. Like, have your window start when it crosses the x-axis. If I said that, then I would be looking for this. Okay.
Yeah, this just like shows the extra on that.
It just shows a little more.
Yeah, on that here.
Okay. Yeah.
I know it's simple, but I'm just saying.
Any other questions on that? All right. Let's take something a little. Actually, no. Let's take that. Let's see if you guys can do this. I want to turn that into cosine, but I want the picture to look exactly the same. So how would I do that? Let's think first. What's the relationship between sine and cosine? Just basic sine x and cosine x. We looked at this when we graphed them on. It's what? Right. It's shifted 90 degrees. Okay. Here's sine, and then what I'll do in well, I didn't want axes, but whatever. I'll do this one in red. And here's cosine. Okay, that's the difference between sine and cosine. So cosine is shifted to the left 90 degrees. Or you could say sine is shifted to the right 90 degrees. So instead of writing it as 90 degrees, what is that in radians? Pi over 2. So if I want to turn this into cosine, I have to shift sine by pi over 2. But which way would I have to shift sine to make it line up with cosine? I would have to shift it to the left. So I would have to add what? So I'm just going to take what's there. I could clean it up a little bit, but I'm just going to take and add pi over 2. And if I do that correctly, that maybe I'll even put that in parentheses, just so it does the division first. So I just added an extra pi over 2, and now let's see if we just turn that sine into a cosine. Close. We shifted the wrong way. I said I wanted to shift.
Would you do it to the side and not the cosine?
Right. Yeah. So for this one, yeah, you'd have to do. Sorry, it would be a minus. The worst thing that happens is you try it and it doesn't quite work, so just try shifting it the other way. So we had it backwards. Now they're the same.
That's so cool. It just like overlaps, and so you don't even know if they're looking
Yep, you wouldn't know unless you knew the original graph as it was drawing it. Yep. So basically what that shows us here is the horizontal shift identities. If you have a cosine function and you wanted to turn it into a sine function, you could add pi over 2. But we put, let me graph that, just to double check that that's right. I'm going to graph cosine x and sine x plus pi over 2. All right, so we've got cosine x and sine x plus pi over 2. Pi would be better. Order of operations, I think, it'll do the division first, so you really probably don't need parentheses, but let's just check it. Ignore the window. Yeah, so what I have on the board is correct. Cosine of x is the same as sine of x plus pi over 2. And you can also do it the other way. Sine of x equals cosine x minus pi over 2. So shifting sine to the left, pi over 2, makes it cosine. Shifting cosine to the right, pi over 2, makes it sine. Okay, so you can turn sine into cosine very easily just using a shift of pi over 2 radians. So any questions on those identities? So the last thing we're going to look at is solving trig equations on the calculator. Now, before we look at doing it, any thoughts about solving trig equations? How these would be different than like an equation like this? What would be the big difference if you solve this kind of equation on top versus this one on the bottom? And I'm focusing on the solution itself. Think about what kind of function is this? 2x plus 4. Like if you were to graph y equals 2x plus 4. It's linear. What if you graph this? No, it's not linear. What is it? It's periodic. Okay? So does that give anybody a hint? When you solve this kind of equation, what would happen? When you solve a periodic equation? Yeah? If you have at least one solution, yeah, you're guaranteed to have how many? Can you be more specific than more than one? 5? No. More than that. What? Infinite. Right? When you're solving a periodic equation, think about periodic. It's a pattern, right? So if you draw a graph and it crosses it early on somewhere, well, it's just going to keep crossing it at those two spots every single period. So if you have one solution in a period, you have infinitely many. Now, sometimes they'll ask you to find all of them, which obviously you can't write infinitely many, so there must be a pattern for how often the solutions are occurring, like this one, and this one. They're occurring at regular intervals. So there's a way to express how often this is happening. How often is this solution happening? It's happening once every, in general, once every period, whatever the period is. So if I find this one answer on the calculator, then I can just write it's this answer plus or minus any multiple of the period. Same with this answer here. This answer is also occurring regularly every period. Right? So I can just find that one answer and say plus or minus any multiple of the period, and you'll get another answer. Okay? That's how we would do it if they wanted every solution. But if they ask us to find the solutions within a specific window, they're telling us an x min and they're telling us an x max, and we're just going to find what they want exactly in that window, and that's it. All right? So for this kind of problem, all we're going to have to worry about is finding a couple specific solutions. All right, so let's graph this and see if we can find the solution. Okay. How would I solve this graphically? What would I do with sine x and what would I do with 0.4? Put one of them is y1. Put the other one is y2. Now I'm graphing sine. So what's the range for regular sine? 1 to -1. So really, I don't need to go -5 to 5. And they told me a restriction on my period. What did they tell me to do for x min? And x max? 2 pi. And that's what I'll do. So x min is 0. X max, 2 pi. Yeah, so just see where they're equal, which is where the two graphs cross. Now, as I said, there are infinitely many solutions, but we're only focusing on the two that they said to. What are the buttons I press to find the solution? Second calc, intersect. And then just go closer to your first point. If someone else can do the second point, that would be helpful, the one closer to the middle of the screen. Okay, but the one on the left is about 0.41. And the other one is 2.73. Okay. And those are your two answers. Okay. And those are in radians, because they're values you would be plugging in for x, and anything you plug into a trig function is an angle. So these are actually angles. Any questions on that? Now, if somebody gave me this problem, and they just gave me a regular calculator, okay, and we had a race, who could do it faster? I could do it faster on a regular calculator than you could graphing it. No question. It's a lot easier to type in the way I can show you here. Okay, all I have to do is second inverse sine 0.41. You wouldn't have even graphed the first equation yet. All right, and oh, sorry, it wasn't 0.41, it was 0.4. Okay. And the answer was 0.41. That answer that we have right here is the same answer we got graphing. Right? So that's the way you can get one of the answers, and we'll talk about what I just did later on. Not today. But how about this second answer? Anybody know where that's coming from? There's a way I can do something with that number to get that answer. Nope, you actually would subtract that number from something, 0.41. You'd subtract it from something. Subtract it from what? 2 pi? Did someone say 2 pi? Nope, not 2 pi, because 2 pi would be 6.280. If you subtract it from just pi, watch what happens. You get 2.73. So why did I subtract it from pi? Well, we'll learn later on. But there's a much faster way to do what we're doing than graphing. Okay? But for now, graphing it's pretty easy. It's just not the fastest way to do it. But a lot of times you get two answers. And it all depends on the quadrants. Okay? You have to, what I'm thinking when I find the second answer is I'm thinking of quadrants in my head. And I'll show you something you need to look for with each trig function. Okay? Sine, I can tell you always, sine is always going to be equal to a positive number in quadrants 1 and 3. And if I know my answers are going to be in quadrant 1 and 3, because of a trick I'm using in my head, there's a formula for that. If I know my answers are in quadrants 1 and 2, there's a different formula for that. Or if they're in 1 and 4, there's another formula for that. All right?
I guess we're not going on this today.
Yeah, we're not going to do them today. They're very simple formulas, but for now, I'm just going to show you graphing. Okay, let's try this one, except I need to fix my range backwards. So 0 to 2 pi. The way I had it before would be no solution. You wouldn't have been able to find a number that is bigger than 2 pi and less than 0. So if you wrote no solution, technically, I would have had to give you credit. But now I fixed it. So let's type that in. And what's the highest and lowest that this function is going to go? 2 to negative 2, which is important because if you didn't have that 2 here, how high would this go? Just to 1. So would it ever hit 1.5? No. It would be like having a horizontal line above the wave. You would never reach it. Okay. But in this case, we will reach it. It's the same window, 0 to 2 pi. So I don't need to adjust anything. But this time, the section of the wave that you're looking at, the second solution is off the screen. Okay? It's in the negative part of the y-axis. So we're only going to get one solution. Okay, so you get about 1.45. Okay. Okay, that's not the only answer. There's one other what I call basic answer, and that's probably about right over here. But other than those, the one I just pointed to and the one we just found, every other answer would be a repeat of those two, occurring every period. Okay. But they didn't ask for that, so that's all we have to write. Any questions on that one? All right, so here's one that's a little harder, but really not if you're using a graphing calculator. Algebraically, that would be a little challenging. But you're trying to find where two trig functions cross. Okay, so just graph them and see where they cross. Any ideas how many times they could cross at most? A lot? Well, you're not going to get infinite. Well, I mean, if you consider every solution forever. But we're just going to look between 0 and 2 pi. Twice? Yeah, I'm sure you could come up with a graph that crosses twice. Any other thoughts? How about 3 times? Could you do 3? Like if you had something like this, and you wanted something to cross 3 times, maybe you could have it start at the same point. There's 1. I don't know if you had to go 2, 3, maybe, if you could come up with the right graph. So yeah, it could definitely cross 3 times. And then if you had 2 graphs, and one of them was really compressed, oh, you could have it cross hundreds of times. You could just have it go like this. Then you get a bunch of solutions. But yeah, let's look at this one. Okay, and how many times does this one look like they cross?
3.
Yeah, it's 3, just barely. It's on the edge of the screen. Does anybody have the solutions? 1 is 3.14. Okay, we can easily check that just by going to the table. And we can see that if you type in 3.14, you get the same value in both functions. So they do cross there. Now, the other 2 answers are probably equally distributed around pi. So if one of them is like 1.6 units to the left of it, The other one is probably 1.6 units to the right. But I would just find them separate rather than use that shortcut. 1.7? And what's the other one? Probably pretty close to 4, or a little over 4.
5, 8.
What is it?
4.59.
4.59. Right now, I'm curious, we don't have much accuracy on this middle number, but if we take 4.59 plus 3.14 and find exactly, whoops, wrong number. Take 4.59 and 1.7 and average them and find what's exactly in the middle, we do get pi. So these two answers are evenly distributed around pi. What's that?
We're not going to have
Well, you already did.
The 1.7 is a function
Right.
of 6, so I just grabbed it to 1.7.
Yeah, yep, that's fine. All right, and the last one is an inequality. So what's different about the solution here? Well, what kind of solution do you get when you do an inequality? You get what? You get a range of values. You get an interval. So the answer here is not just x is about 1.7. It's going to be an interval between two numbers. All right, but we still do it the same way. Put 2 cosine x, negative 1.3. And I'm looking for where the trig function is above 1.3. Okay, so what do I have to do first? Yeah, calculate these 2 points. And then once I have those, my trig function is above negative 1.3 in this section, which I'm trying to make look bold, and this section. So let's start to write those 2 intervals I just highlighted.
the one on the left is 2.28.
So what's the left end of this interval? 0, including 0 or not including 0? Including 0. Okay, it says to include it. And we go from 0 all the way up to, somebody had this number right here? 2.28. Do we include 2.28 or no? No. It says do not include it. Or from, does anybody have
It's
4.00?
Yeah.
So 4.00, again, not including it because of that. And what do we go up to? 2 pi. Including or not including it? Not including it. Usually you don't include both 0 and 2 pi because they're the same, they're repeats. So if you include one, you don't include the other. And that's generally how they do it. Okay, and that's your answer. What if they wanted to know where this function is below negative 1.3? What would that be? Yeah. Yep, 2.28 to 4 is where it's below. So any questions on that? All right, so that's some of the calculator stuff we're going to get into. We'll see some of the same kind of stuff tomorrow, except we'll do other functions besides just sine and cosine. But same general approach. All right, so the homework tonight is on 346. And it's 2 through 4, 7 through 10, 15, 17, 21 to 23, 29 to 32, and then 36, 39, and 43. Okay, It's not all graphing, some of it's just on the calculator, so there might not be anything to write down for those problems. So just write, that you did it on the calculator. And then tomorrow we'll finish 6-4, and we have our take-home test tomorrow night, due at the end of class on Friday, which for you guys will be 8:30. Okay? Because it's only half a class.